So I have opened the AC disconnect, isolating the inverter from the utility connection. I've opened the DC disconnect, locked it out. I also locked out the AC disconnect. I've removed the plexiglass shield that protects you from touching energized parts, and now we're ready to set up our connections. With the GFL-1500, the red connection goes to the positive, the black test lead goes to the negative, and the green test lead goes to ground or the earth. This DC disconnect opens both the positive and the negative conductors, so they're both isolated from the inverter and from any ground connection. If you have a system where one of the DC conductors has a connection to earth, maybe a functional grounding connection through a ground fault detection fuse in a central inverter, you need to lift that connection so that the DC conductors are isolated from the ground, or else the GFL-1500 will not work properly. That ground fault connection is a path for the signal to ground, and it will show a false result there. So I'm going to go ahead and make my connections. I've got my personal protective gear on. I'm going to put the red on the positive bus bar. I'm going to put the black on the negative bus bar. And I'm going to put the green on the grounding or earth bus bar. So I'm going to turn the tool on. I'm going to set it to analyze mode, and we can do a test run and see how our system is operating. So again, I've got everything all set up. The red is to the positive bus bar, black to negative, green to the grounding or earth bus bar. And now I can hit test, and it should run the analyze mode test. So in this system, we have 1,106 volts open circuit between the positive and the negative. We have 0 volts from positive to earth, and 0 volts from negative to earth. So this is a good test result. No ground faults found in this system.